Testing. All right. Now I feel cyber. All right. Is it not? This is ridiculous. Well, thanks everybody for staying out. You guys are the last defenders of our country. So just a little bit about me to start off with. I'm nobody really special. I do work in web application penetration testing exclusively, so I do this stuff on a daily basis, and I look at code and I do static code analysis for a large government program based out of Charleston, South Carolina. We look at probably 2.5 million lines of code, and it's an agile development environment, so we do 12-week releases, and we're constantly scanning, constantly updating, using any tools. We have carte blanche to use whatever we want to do to test this stuff to make sure that it's protected. I do enjoy talking about it, so feel free to come talk to me after the show, or feel free to check me out on Twitter. I'm not really angry, I just look this way. So let's get started. So for anybody who doesn't know, OWASP is an organization that looks to improve web application security. Like, that's their thing. They go out and they're doing all kinds of crazy stuff with coming up with new tools, with coming up with templates on how to properly secure code, how to attack websites, how to secure the websites. They put out a lot of cheat sheets. They spend a lot of time for free to give us the resources to make our applications better. For anybody who's never went out to their site, I highly encourage it. It's something that I'm looking at an almost daily basis. And one of their most famous products is the OWASP Top 10. And it's not really any authoritative list as far as statistical analysis. They don't do breach reports. They don't do, like the Verizon breach report. They just have a bunch of people that sit around and talk about the things that they see on their networks and their applications, and they try and figure out what the best and the worst was since the last OWASP Top 10, which turns out that was in 2013. So it's due to be updated soon, but they don't put any dates out. And I haven't really felt a lot of pressure with them putting a new one out because it never changes. The same top 10 are always the same top 10, and they have been for the past 3 top 10 lists, and we just keep going on doing the same things over and over, which is where guys like my team come in, and we go and we talk to the developers. So when we find these vulnerabilities, we go back and we teach developers how to fix them in an ongoing architectural basis. We don't just go and fix individual defects. We change the frameworks and we teach them, and we go and talk to individual guys and get them excited about doing security and changing the mindset going forward. So we will, I know everybody's probably itching to get out of here, so I'm going to speed through some of these ones that are a little bit more passive when you're doing an attack. I'm just going to jump right into it. I didn't pick any specific order to do these. I kind of grouped them together in the beginning for some that are more passive. You don't specifically attack some of these vulnerabilities. You just look for them in applications and try and find out, well, I found this weakness. And the first one is components with known vulnerabilities. And Tim covered this a little bit, or a lot. So you go through and you get to know an application, and you see that it's using imported libraries. Like some of the stuff we look at import a lot of third-party libraries. And sometimes the developers don't know, don't care, or don't have the time to go out and ensure that they're using the latest version with no vulnerabilities. So as an attacker, look for that stuff. Go through and see if they're using jQuery, if they're using NoSQL, go through and look, and as an attacker, you can find the keys to the kingdom in the libraries that other people are importing. So the application that you're attacking doesn't always have to be the one that was written by the developers of the company you're testing. Go through and find everything that's attached to that application and see what you can do with it. Kind of on the same path there, security misconfiguration. This is something that we don't have to deal with too much, but in the commercial space, you get a lot more people who put applications up rapidly, or it's smaller shops and they may not have a full IT staff to do their Apache and IIS configurations, so they go around and they do the minimum effort to get the thing working. We need to get it shipped, we need to get making money, or else we're all going home, right? So you can go in and you can find misconfigurations on all the servers, you can find WAFs and load balancers misconfigured, and all that stuff will open the application right up to you. You can find databases exposed to the internet. All these things fall under security misconfiguration, but again, it's not really something that you're going to attack unless maybe you hand it over to more of a network pen test style. It's not direct application related. One of my personal favorites dealing with medical health systems is sensitive data exposure. A lot of the things that we deal with, people don't want out there on the internet. You don't want your health data, your PII, your PHI, your social security numbers, all those types of things out there for Shodan and Recon NG to scrape off of every site on the internet. So as we go through these applications, the things we look for are what we classify as privacy violations, where sensitive data is exposed out in a way that it's not supposed to be. So this covers a lot of different types of categories of data. One of them is comments, things that are not supposed to be in the application. I've done engagements where I've been through applications and there's comments that just tell me exactly what I need to know to go to the admin page with no login credentials, right? So the stuff is there. But the more subtle side is the things that where the application is functioning correctly and the developer didn't necessarily do anything wrong, they're just not protecting it. So if I can go through and do a database call that brings back some kind of subscriber record, and I can just change a parameter to do a different identification number and get back somebody else's data, that's kind of the same thing, because then I can set up a script that will automatically pull down every single one and sell it to the Chinese. Not that I would ever do that. So if you have access to the source, make sure you look at that. Find all the privacy violations. Find anything where there's just information that's not supposed to be out there. But every web application shows you half of the source at least. You can look at all the JavaScript. You can look at all the HTML. Both .NET and Java. You can make mistakes where the back-end comments get included into the front-end code. So all of your JSP comments, your C# comments can get put out where nobody needs to be seeing them. Have some kind of practice as a blue team side. Have a practice to strip your comments out before it goes out. So as an attacker, that's one of the biggest things you need to be looking for first off. View source. Every time you want to look at an application, get started because you're going to find lots of goodies. Moving right along. Unvalidated redirects and forwards. This is extremely powerful because you can get users to execute code very easily in a way that will do anything you want to their browser. So you see this on essentially every single application that you come across, right? Everybody logs in and logs out. You're getting redirected around, and nobody really pays attention to how many times you're getting redirected, and most developers don't think to secure this type of stuff. Because if you don't have control over where you're sending the user, then you don't have control over the application at all. And I can execute any arbitrary script by sending someone a phishing link that redirects them on the logout to mysite.ch. So look for these types of things. We've had them on our government systems, and it's a little bit tricky to fix. So developers will skip right over it because they don't want to have to do it. Everybody just puts here's my first question. Where do you typically see the redirect URLs when you're doing the login, logout, and moving around through an application? What's that? So where do you see it? If you're an attacker and you're looking at an application and you click the login button, where are you going to look to see? Not quite. The address bar, right? No, the URL bar at the top, the address bar. You win a notebook. So it's right out there in the address bar for everybody to see, and nobody cares about that stuff, right? But what can you do as an attacker? Just change the address bar, right? Change the redirect URL in a man-in-the-middle or a phishing attack or any number of ways. So it's out there. When you see it in the address bar, that is a GET request, right? And how many of you here know the difference between a GET request and a POST? Anybody not? So on a POST, you're not going to see any of the parameters. So in a POST attack, or in a POST request, if you don't see the parameters, how are you going to send this in a phishing email to send someone to click on a link that you want them to click? So you do a hyperlink, but how do you, if a server is expecting a POST, how do you use something where you can include the parameters in the link?
Mark Baggett wrote something called get to post, which is a Python script that takes in your parameters on the URL and then creates a form in the browser that is auto-submitted as a post. You can download that Python script and do it.
Can you win something? So there are other tools where you can go both directions. You can do get to post and you can do post to get. One of the things I do a lot is I'll go the other direction and do a post to get. So I very rarely see server administrators that will limit the HTTP verbs to only post, right? They just do whatever's available. By default, Apache does post and get. A lot of times you can just open up Burp Suite, say change request method. You can do Mark Baggett get to post and get around this type of thing. So you can still execute the same type of attack without changing anything on the phishing message. The next one is broken authentication and session management. And this is something that's extremely difficult for developers to get right for some reason. They continually try to just invent their own methods of session management and authentication, and we see it all the time where people will reinvent the wheel, come up with bad practices and invent their own methods. So how do you find this stuff? What types of things are you looking for as an attacker? In session management, one of the worst things you can do is session fixation. So when you're going through, you can do tests for these with Burp Suite. And what you're looking for is when you go to a web application and you see the session ID before you log in, and then you log in successfully, if you have the exact same session ID, it's called session fixation. So you can go through and start guessing session IDs, and you can start guessing other people's session IDs. A lot of times it's not a cryptographically secure hash. It's just a random string of characters. Other places that you can see broken authentication and session management is password resets and emails and homegrown crypto or just poorly implemented crypto. You find this stuff all over the place, and it's really easy to detect, and you don't have to be a crypto wizard to see when somebody's using an MD5 with a static salt. It's pretty easy to break. Insecure direct object references. This is another one that Tim covered a little bit, and this is just grabbing things that you're not supposed to be grabbing, right? Can you go to a web application and grab a document and then just put that in your browser bar and go to it directly without the application doing any kind of authentication on you? Can you go through and just start randomly guessing the IDs on the documents or the objects you're trying to get to? Can you pull back subscriber records that don't belong to you, or can you execute operations in the application that you're not supposed to be able to, because people don't secure the, what's the word I'm looking for? Yeah, people just don't do a good job of checking to make sure that the object access on the second transaction is secure. So everybody, or a lot of developers, will make sure that when you log in and you can see the pages that you're supposed to be seeing, but they don't say that when you go to do the direct object reference that you have some kind of policy on the second call that this user has the permissions to get that object. So it's very, very common because it's something that a lot of developers don't think about. If you're authenticated, then they assume that you're already a good user and you're doing the things that you're supposed to be doing. Another one that pops up a lot in this is path manipulation. If you're supposed to be looking for documents, you know, in ./whatever, or in, you know, images/my file, but you can throw in ././././, or start working your way out from there. You can figure out where you live on the server and generally figure out where to get to the good things on the server that you want to get to. Path manipulation is very powerful, and it helps a lot with network pen tests as well, once you can get to Etsy Shadow and stuff like that. With path manipulation and insecure direct object references, you can get to the point where you can, if you can figure out what directory you live on in the server, you can go towards uploading a web shell and executing the web shell. If you don't know where you are, it's pretty hard to get back to the web shell once you upload it. I just covered that with talking about it. So this is the type of thing where when you're looking at the source code for an application, the developer is going to go through and just look at the things that they expect. Oh yeah, there we go. There's the //slashes. So if you can get to some kind of path manipulation like that, then you can own the server as well as the application. This is one of my personal favorites because I like to use it in my daily life, my daily surfing life. Anytime application developers do JavaScript access control, it's just game over, right? One of my favorite vulnerabilities that we talk about from our work program is we were able to just cut checks for $24,999 because the developers thought that by graying out a button in the browser that operation was secure, right? So what do? How do you test that as an attacker? You open up the JavaScript console, the developer console. Every browser has a way where you can just go in there and say, I think I have another slide for this. Yeah, so you can just go in there and say, from enabled is false, change to enabled is true, right? They didn't change anything on the back end. The method is still wired up, and it still is going to cut that check for $24,999, right? And the reason why we limited it to that is because we knew that at $25,000, I was going to have to send 2 phishing emails to get the check cut and the second approval, right? So I only wanted to send 1, so we capped it at $24,000. So we see this all the time. I have accidentally left Burp Suite open and surfed the internet and seen things where I could, you know, just say enabled equals false. Something you can do. Somebody was talking about paywalls a little bit earlier. When you go to New York Times paywalls, you can just open up your JavaScript browser console, disable the JavaScript functionality, and get to whatever you want to do because all of that is handled in JavaScript. So that's something that is on the entire internet. And that's a really easy way to practice because you're not really hurting anybody until you submit, and then it's illegal and you're going to jail. So this is another one of my favorites, and this one can get a little bit tricky to talk about because it involves having your own server set up so that you can do some reflection, and maybe doing some phishing. But it's an extremely powerful attack that is, it's kind of gotten popular in the last year or so, I don't know. But you can make a lot happen with cross-site request forgery. And what happens here is the user has to already be logged into the application. So the user logs in, and they're having a good old time doing their daily reports and whatever it is that users do. And you see you have the bad guy there because he's wearing a black hoodie. So the user gets a phishing email message, and the phishing email message goes towards the bad server, right? So you're going to, instead of mysite.com, you're going to mysit.com. And the attacker already knows a little bit about your application, so they know something that they want to happen, right? They have a goal. This is more of a targeted attack. It's not an accidental drive-by. It's a lot of times included in watering hole attacks and things where they know a little bit about the environment and they know a little bit about the people that they're trying to get after. So when they get phished, they tell the user's browser to execute something on the original application. So since they're already logged in, they're clicking that link, and maybe the bad application has an iframe or something like that, so the site's mirrored, they do some redirection, and it goes back towards the original application, and again, they're cutting checks for $25,000 with the permissions of the originally logged in user. So when you're doing your incident response, on the server side, you're just going to see a normal call coming from that user who has those permissions, and they're going to be explaining why they're making those, doing those operations. Something it's super powerful, and you hear a lot about it in some of the recent attacks. Cross-site scripting is, everybody talks about XSS, right? It's everywhere. It's always happening. The web is so complex, and Web 2.0e, that XSS is everywhere. And even giraffes can do it. So what happens with XSS is people will take a piece of the website, take a form submission, and change the form submission to do something that the form is not normally supposed to be doing. So I'm going to try and flip over and do my demo here. So what I want to do with cross-site scripting is inject some other type of code into the form submission so that I can get it to do what I want to do. And what happens, there's two main types that people talk about. There's reflected and there's stored. And I'm going to show you guys some reflected, if everything works for me, which is not.
What's with the giraffe? I missed that. I catch everything else. Giraffe, database.
It's just stupid.
Fair enough. I love it.
Yeah, no. About half of those arrows I put on there. Oh, I know what I need to do. Hold on, I'm making my VM show up so you guys can see what I'm doing. Maybe. So, okay. We're going to move on a little bit while I'm doing this. With cross-site scripting, one of the things that I'm going to show you as soon as it's working is I'm changing the way that the web output works after it hits the server and comes back. With reflected XSS, it has to hit the server first. One of the things you see happen a lot with junior testers is that they'll do something in the JavaScript console, and they'll do something, and they'll get the XSS to pop up in their own browser, but it never actually hit the server and came back, right? In order to make this work, there has to be a reflection. So when you just make it pop in your own browser, all you did was XSS yourself, and you're not actually hurting anybody. Why is that not showing up? There we go. 20 minutes later. So I'm using Mutilidae for this. because I'm not going to jail for you people. So this is an application, and I choose to use it on the Samurai WTF framework that's kind of, it's like Kali, but it's more specifically built for web pen testers. So it's got all kinds of good stuff for learning how to do web pen testing. What the hell? It's all free. And one of the reasons why I like this one more than others is that it's got different levels of security and different levels of other tests built in. So I can go through here. Right now hints are enabled. So I'm going to shut the hints off. But you can go through here from an extremely basic level and say, I want to go to the OWASP 2013 top 10. And I'm going to try cross-site scripting, and I want to look at the absolute most basic XSS available. And so they have a form set up where you can try and figure out what's going on. So some of the things you're looking for, and I want to show you the whole process here going through this, is where does this come back when it works correctly, right? So if I'm just using this, and I think this is going to fail because I don't have any internet. But if I'm using this correctly, what happens when the site works? Right, so, but what I'm looking for is where does that reflection come back in the web page response? Now, because we don't have any internet here, Google's not going to resolve and we're not going to be able to see what happened. But imagine in your mind that we just got an IP address back, and it shows it on the page when you do this with an internet connection. So the first thing I'm going to do is right-click and view page source. And I'm going to find the area where, this one happens to be at the very bottom, I'm going to find the area where it shows the output that I was looking for from the correct form submission. Right? So I'm going to see the HTML in the source for where the form response comes back. So when you're doing this, you're going to look for, like this location contains dynamic output. So you're going to look for the stuff on the page, and it's going to match what's in the source because it's just HTML. So now you got to figure out, how can I break that HTML in the middle and insert my own code and make it do what I want to do? How am I going to change the script that's executed on the site? So, for example, we're going to close that window and go back here, and I'm going to do a string that I know works for the sake of a better demo. And I don't want to type all that out and get it wrong. So what I put in here is an image, an HTML image tag with a source of X, which is not a proper image source, right? So it's going to fail. And a script tag of on error alert is XSS. And we use this because it's an extremely quick way to demo the fact that the script works. Right? So we know that this works because we got the XSS. But like Tim was saying, we're looking for more impact, because if you're showing this to the business leadership and they're saying, great, so you can put a pop-up on my screen, there's zero impact. This is your quick test. But where do you move from here? Right? So what other types of actual impact are you going to be able to show leadership to get something out of this, right? So another good quick one is to use, kind of the exact same thing, but instead of just a basic string, document.cookie is another quick one, and this is going to give you your session ID and anything else. A lot of these applications use some really critical stuff in the cookies. So taking this as, one small step forward, it's still just a pop-up box with some stupid data in it. But where we're going to go from here is you get your site back up, and you can do the phishing emails that will send that URL. Somebody clicks on it. Or you do a phishing campaign and you get 100 people to click, and then you just got information on 100 users in the company. The next step is to start breaking into the browser exploitation tools, the beef, browser exploitation stuff, where you can actually control the browser. Because if you can control the browser through JavaScript, you can do literally anything. You can do time travel with JavaScript. It's just very hard to demo it quickly when you're doing the little test. But what if you're not looking at a single submission web form? Some of the stuff that we see a lot are Ajax sites that have multiple submissions over and over again because they're always doing stuff on the back end. And so where do you go from there for web pen testing? That's where Burp Suite comes in. Burp Suite, for anybody who hasn't heard of it, is a browser proxy tool, testing tool. So everything I've been doing now is going through this proxy, and it can see every request and response before it gets sent out to the server. And this is a free tool. There's a pro version for $300. But if this is something that interests you, make the investment and get the pro version, because it adds a lot of functionality that's maybe rate limited in the free version or unavailable in the free version. But for the basic testing stuff I'm doing right here, this is all free. So all of these tests, screen is tiny, show up in the capture here. So what we're going to do now is we're going to look at another XSS vulnerability here. With I'm just going to go straight to the URL. Oh yeah. So maybe you're looking for Mark Baggett's tools on some website that gives you a list of pen test tools, right? So this one doesn't have a form submission where you can put anything in. Developers tend to think that because it's a drop-down box, it's somehow more secure than a text field, which is not the case, right? Anything that you can do prior to submission can be altered. So I just chose Nexpose, and it brings back the information that it has in the database about Nexpose. And so we want to see what Burp Suite caught, right? So Burp Suite caught tool ID equals 7, which is kind of meaningless for us because we don't want to just put a bunch of numbers in there and get the information that they already have in there, right? So that's when you start fuzzing it with special characters and you see how you can get it to break. Now, I'm not going to sit here and type all this stuff out, but what you see is by putting a double quote in there as the first character, you get some special circumstances. So the cool thing about Burp Suite is it will stop the connection midstream and allow you to change things. So I want to see what Hailstorm is. I'm going to turn Intercept on Burp Suite and look up Hailstorm. Now this is going to sit here forever because Burp Suite is over here waiting for me. So my proxy intercepted this, and I can change this value to be the string that I know works, right? And so when I'm doing this process, it is a lot of testing and getting it wrong. I go through this wrong 100 times before I find the one right string. Unless it's one of the lucky ones, if I go out to the XSS cheat sheet put together by RSnake and find a lot of, there's like 1,000 different tests on there. So you can put the tests in and kind of get stuff back until you find one that you know works. And so you forward that, and it gets sent out to the server and comes back with your XSS pop-up, right? So you can do that exact same process on Ajax applications that are doing these calls on the back end, and you can do them directly with application calls that don't have to go through the web form submission first. If it's done in JavaScript, or if it's calling different forms that are on the server, you can call those JavaScript methods directly without actually submitting the web form. So you can send those out in phishing campaigns, and you can send them out in, other types of attacks. So that brings us to my personal favorite, which is darkness. There we go. Which is injection, SQL injection. SQL injection is not the only kind of injection. Anytime you can get code into the middle of somebody else's code, that's injection. So it happens with HTML, it happens with JavaScript. SQL is just the most talked about because it generally has the most impact for breaches in the modern world. So you can get anything you want out of the database. You can put anything you want in the database. You can attack the operating system through the database, all through the magic of SQL injection. When you're doing this, you don't have to be a wizard DBA, and you don't have to sleep dreaming about PLSQL. As you go through the process, when you go to every website, and you can do this on, I do not recommend doing it on internet sites because you don't want to go to jail, but start with Mutilidae, start with Metasploitable, work on learning what it takes to find SQL injection. The first thing you do every time you go to any web form when you're messing around this stuff is just put a single quote in and see if you can get error messages back. So if the application is giving you error messages, it's going to give away a lot of the stuff that you need to know about what happened, right? So these guys aren't suppressing any kind of errors on this site on purpose because it's a training tool. You might not always get this, but you typically get a lot of this. You'll typically get some kind of failure. You'll see that, MySQL returned an error message. You'll see that things are broken, and you can get information from that. Every bit of information that you can get from this failure gets you one step closer towards successfully executing the SQL injection and using SQL Map, right? SQL Map is an amazing tool for doing this stuff, and we'll come to that in just a minute. So once you learn some of the basic SQL injection strings, like there's basic ones that you always do as your first test. So yep, they're just magic. So, like, I know that I don't have a valid login to this website, and I want to see if this works. So the first thing you do, everybody always makes an admin account, right? Like, you stand up a web application, and you're like, well, we got to have some kind of admin. And so you put an admin in there, and you just know that this string is going to be the magic one. Single quote, space. I'll do it over here so you can see it. Single quote, space, or 1 = 1 --. Now, when I do this the first time, I think it's going to fail. Let's see. For once, I'm hoping my demo fails. So, it did. So, for a copy of Black Hat Python, who can tell me why that magic string failed? And I'll bring it up again right here. Right there at the bottom. Nope. Close. Nope. Right there. Boom. Yep. It's missing a space at the end. This is your book. You got to have a space at the end when you're doing this because it's a comment and something has to be in there to start the comment. So if I do this exact same thing, that's where I stopped last time. So you add the space and go right back over here. It still doesn't work. Oh yeah, it did. That was the user list. So this just dumped out everything in the database, right? So I really wouldn't do a lot of this manually when I'm doing a normal test because I don't want to be sitting here typing out attempted database strings over and over again. I'm just going to go straight to SQL map. So again, for the purposes of expediency, I've already done some of the work ahead. So we know that that's our website, Mutilidae. They have an indexed page, login.php. And because they're using a post and not a get, we're going to use the data section. So if it were a get, you could put it all in the URL, just the normal parameters broken up with right after the question mark. But so we're going to do it like this. Submit button, the button is login because that's what the form requires, and then we're just going to ask for the banner. So SQL map is going to go through there and give us a whole bunch of stuff because it can do it infinitely faster than I can because I'm a terrible typist. So we got the banner. We know that it's running on Linux Ubuntu. It's Apache 2.4.7, and our DBMS is MySQL, but that's kind of boring. So we want to go for, you can start to work your way out from there. Find the current user. We're running as root at localhost. It's probably not a great idea. You can just start, this is going to run for a while and I'm going to kill it, but you can just start dumping the entire database out. And since we're running as root, it's going to get everything that root can get permissions-wise. So all of the schema tables and everything that you could possibly want. But some of the more fun stuff with SQL map is using the command shell stored procedures. So you can send shell commands to the OS through a stored procedure inside of every backend database. A lot of them have them disabled now, but thanks to the magic of SQL queries, you can just re-enable the stored procedure. So if you can get SQL injection to begin with, the only way that a really good DBA can disable the command shell stored procedure is to remove it completely. So they would have to know a lot, about defending databases to specifically go in and remove the command shell stored procedure. You can upload files from here. So if you can get SQL injection and maybe you can't get the kind of stuff you want, or if you're just looking for a bounce point as an attacker, you can upload your web shells. You can create any kind of file you want. It's all done through file creation as opposed to like an upload process. So you have to upload the text directly to the file. It's extremely powerful, and lots of breaches. So let's go into our questions section. Does anybody have any questions before we start asking you questions? No, I was that good.
All right. So, you ready for some trivia questions? You got some?
No.
I've got it. All right. So, first, what was the name of the web application training tool